My name is Madhul Koda and my roll number is 17EC01036, and this is a report on lab 2. The aim for this lab is to work on a real-time PPG signals. So in the previous lab, our aim was to study some filters and we processed previously recorded data, but in this lab, our aim is to process a real-time PPG signal and perform filter operations. So first of all, we will know what is a PPG sensor. So what is the PPG sensor? PPG sensor is used to detect the blood volume change in the macrovascular bed of tissue. The emission of the infrared light by electricity which penetrates the skin and the blood vessels, and this light is captured by the detector to measure the blood stream. The result of the PPG signal depends primarily on the flow of the blood and the oxygen to the capillary vessels in each heartbeat. It is not precise as ECG, but it is small and portable. As you can see in the image, the LED light is emitting the infrared light, and the photodiode is capturing the received light. Uh, so. Uh, so the PV sensor will look like this. It is the front side, it is the back side. As you can see, it is a LED light which emits the infrared light, and this is the photodiode which captures the received data. We have to connect the PV sensor to the Arduino board on which we are doing the processing, and to connect the PV signal to the Arduino board, we have to connect the S pin to the analog pin, and the plus to the 5 volts and the minus to the ground. After connecting the PPG sensor to the Arduino board, we have to take the input from the PPG sensor and through the Arduino board, and we have to perform some filter operations. So the code and the results are. This is the first code. We are performing some basic operations. At first, we are taking the input through the PP sensor to the Arduino board, and then we are sending the input into the moving and filter of order 8, and then we are sending it into the derivative filter of order 1, and then into the derivative filter of 3 point center difference. So for taking the input to the through the PV sensor to the Arduino board, we have to write this set of code. The analog read of A of 0 because we are connected the PV sensor to the A0 input pin of the Arduino Duo board, and then we are sending the input into the moving average filter of order, right? And the output from the moving average filter is sent into the derivative filter of order 1, and then to the derivative filter of a 3 point center difference. So the output of this code is as follows. So we have got the four signals. This is the input signal of 500 samples, and then we are sending it to the moving average filter of order 8, and we are getting the signal a smoother signal, and then we are sending it to the first order derivative filter, and we are getting the output as this, and then we are sending it to the 3 point center difference, and we are getting the output as this. So this is the first code, and this is the second code, and we are performing the baseline drift removal. As discussed in the lab 1, we are taking the large L value of moving average filter, and then we are removing the low frequency noise from the original signal. So here we are taking the input of 100 samples, and here we are sending the input into the 400 order moving average filter so that we can get the low frequency noise, and here we are removing the low frequency noise from the original signal, and the outputs are as follows. So as we can see, we got the 3 outputs, and the first one is the original signal, which is a blue one, and the red one is the baseline drift, which is a low frequency noise, and the green one is we got the green one after subtracting the red one from the blue one, which is nothing but the removal of the low frequency noise from the original signal. So this is the second code, which is a baseline drift removal, and next we will be performing the ECG sampled data which we have given, which so this is the second code. We are to perform the similar operation similar to the first code, which is a real-time one, except we have given the input sample data of 1,000 samples. We are performing the similar operation to the real-time one. We are sending the 1,000 sample data into the moving filter of order 2, and then we are sending into the derivative filter of order 1, and then to the derivative central 3 point central difference derivative filter, and we are also performing the baseline drift so to remove the baseline drift also. So we are taking the moving filter of order 800, so to get the low frequency noise, and we are separating the output from the moving filter of order 800 to the original signal in order to remove the baseline drift. So outputs of the two signals, two sample data are as follows. So this is the first sample data of a ECG sensor of 103, and So it is a original signal, and it is a moving average filter output of second order, and it is derivative filter output 3 point center difference, and it is derivative filter output of first order. We have also done the baseline drift removal of the ECG 103 sample data. So this is the original signal, and this is the baseline drift of the ECG 103 sample data, and it is a result signal after removing the baseline drift. The second we have given the second sample data ECG 113, and it is the original signal, and it is a moving average filter output of second order, and it is a derivative filter output of 3 point center difference, and it is a derivative filter output of first order. We also perform the baseline drift removal of the ECG 113 sample data also. It is a original signal, and it is a baseline drift, which is a low frequency noise of the ECG 113 sample data, and it is a result signal after removing the baseline drift from the original signal. This is a report of lab 2, and hope you like the video. Thank you.